Hello friends, today we are going to discuss very important topic, that is electrochemical series. It is important table where different electrode potential of elements, different electrode potential of different electrodes are arranged in a increasing or decreasing manner. That is called your electrochemical series. Already you know that electrode potential electrode potential of the elements generally two types. One is oxidation potential, another one is reduction potential. This oxidation potential means tendency to lose. Tendency to lose. Here reduction potential means tendency to gain. This is the difference. If losing tendency is more, that is called oxidation potential. If gaining tendency to accept electron tendency is more, that is called reduction potential. And this oxidation potential and reduction potentials generally expressed as E naught oxidation. This is called E naught reduction. This oxidation potential and reduction potential just opposite inside, means E oxidation is equal to minus of E reduction. Both are in opposite sides. And it is expressed in the unit volt. The unit of electrode potential is volt. E oxidation equal to minus E reduction. But generally, for calculation, always the potential is taken in terms of reduction potential. Generally, E reduction potential is taken for calculation. For different calculation, we are considering which potential? Reduction potential. And here, what is electrochemical series? Electrochemical series, just you see different potential of, this is a half cell, these are different half cells, their reduction potential is given. This is reduction potential, E naught reduction. Here the table indicates the value is decreasing order, plus value, and here minus value. So decreasing order. So this is called electrochemical series. What is ECS? Electrochemical series. ECS. Short form is ECS. ECS means arrangement of different E reduction means reduction potential. Arrangement of different reduction potential of half cells, or you can say different electrodes, different elements. Arrangement of different reduction potential of half cell in order of, in which order? In order of decreasing. Arrangement of different reduction potential of half cell in order of decreasing their values. Arrangement of different reduction potential of half cells in order of decreasing their value. This arrangement is called electrochemical series. What is the utility? What is the importance of this electrochemical series? Why we are using this table? What is its importance? What is its use? Let us discuss this one. Here, application. Application of electrochemical series. First application is selection of anode and cathode. Selection of anode and cathode. We know anode means oxidation reaction takes place. Cathode means reduction reaction takes place. Anode means oxidation and cathode means reductions. So, as in cathode reduction takes place, cathode should have high reduction potential. Cathode means more reduction potential. Anode means oxidation means low oxidation, low reduction potential. As the data will be given in terms of reduction potential, so we should discuss by taking reduction potential. As cathode, at cathode reduction reaction takes place, so more reduction potential means will be used as cathode, and low reduction potential will be used as anode. For this, for example, here you take silver and iron. For example, you take silver electrode, and the value is 0. E naught value inert value of this silver electrode is 0.80 volt and inert value of iron Fe3 plus to Fe2 plus that are given as per this 0.77 volt. So from these two data indicates silver has a high reduction potential and iron has low reduction potential. So silver will be cathode because reduction potential is more and your iron will be anode because low reduction potential. So like this selection of anode and cathode also we can maintain using electrochemical series. Second application of electrochemical series is calculation of standard EMF. Here. Calculation of standard EMF. If a complete cell is given, the EMF will be E of cell will be standard value will be always equal to E of cathode minus E of anode. This is very important for this. Suppose you take these two cells, these two half cells, silver half cell and iron half cell. In this above cases, what is E naught value, standard value of this cell if you use? It will be how much? Higher value 0.80 V minus 0.77 V. Your answer is 3 0.03 volt. So 0.03 volt is the EMF of this cell, complete cell. If you take silver and iron, you will get the inert value in this much. The electromotive force of this cell is 0.03 volt. And this electromotive force EMF, when it will be positive value, when EMF will be positive EMF, positive EMF indicate spontaneous of the reaction, that feasibility of reaction, feasibility of reaction. If inert value is positive, that means reaction is possible. Feasible means possible. If negative inert value, the difference is negative. If it is negative, then non-spontaneous. So from inert value calculation, we can say whether the reaction can take place or not, whether the particular electrode will be anode or cathode. That selection also we can know from the EMF value. EF value for particular spontaneous reaction, EMF always should be positive for feasibility of reaction. Then third application of this EC electrochemical series is reactivity of metal. We know metals has a tendency to lose electron. Metal means it has tendency to lose electron. To lose electron means low reduction potential, low E0 reduction. That means if reduction potential is low, then metal can easily lose electron. Low reduction potential has more tendency to lose electron. And if reduction potential is high, then tendency to lose electron is less. That's why reactivity of metal depends upon the outermost electron. If outermost electron is loosely bonded, the metals has highly reactive. Ionization energy will be low. The ionization energy of the metal will be low, means it has low reduction potential, more reactive. So this is the reactivity order. For example, you see the table. Here the table is, suppose silver and copper. In between silver and copper, silver value is how much? 0.80 volt, and for copper the value is 0.34 volt. So as silver has a high reduction potential and copper has a low reduction potential, that means copper is more reactive than silver. Copper is more reactive than silver. That means for reduction potential value, we can say which metal is more reactive. In the electrochemical series, lithium has highest reduction potential. Lithium has highest reduction potential. So the tendency to lose electron in case of lithium will be more in the aqueous medium. So on the basis of reduction potential, we can say what is the reactivity of metal. Then oxidizing and reducing nature. Oxidizing and reducing nature. Is very important. What do you mean by oxidizing agent? Oxidizing agent means, you have to know this. Oxidizing agent which oxidizes other itself is undergo reduction. Itself undergo reduction. This is very important. Oxidizing agent means itself is reduced. It oxidizes other, but itself is gaining electron. That is called oxidizing agent. As oxidizing has tendency to accept more electron, reduction means gain of electron, itself undergo reduction. If tendency to reduction is more, that means oxidizing character is more. Oxidizing character will be more when the reduction potential will be more. That means more E0 value. This is very important. For oxidizing agent, reduction potential should be high. And reducing agent means low E0 value. High E0 value oxidizing agent, and the low E0 value is reducing agent. For example, just to compare last two, sodium and lithium. You take sodium and sodium value is how much? 2.71 volt, and lithium value is, as per the data, is 3.05 volt. As lithium has a high reduction potential in compared to minus value, as lithium has minus sign, I have not written here, write minus sign, here also minus sign, I forget to write the minus sign. As lithium has low reduction potential, minus 3.05, it is minus 2.71. This is low, this is high. What is the conclusion? Low reduction potential will be acts as better reducing agent. Low reduction potential will be better reducing agent. What is the best reducing agent? Lithium. So reducing nature, if you compare, lithium will be greater than sodium. Reducing nature. If you compare reducing nature between lithium and sodium, lithium has more reducing character than sodium because low reduction potential. So just oxidizing character is opposite. In between fluorine and chlorine, fluorine the value is 2.87. Fluorine value will be 2.87 volt, and chlorine value is, as per the data, as per the table, 1.36 volt. So high reduction potential is better oxidizing agent. So oxidizing character, fluorine is greater than fluorine, that is oxidizing character. Oxidizing nature. So these are the theory. Which is a better reducing agent? Means low reduction potential. Which is a better oxidizing agent? High reduction potential. This is the very important application of electrochemical series. So this value can be used in different problems. Thank you.